Hello everyone. In this video we will be learning about systems of linear inequalities. The previous lesson was about only linear inequalities. We learned how to graph a linear inequality, but here in today's video we will be learning about how to graph a system of linear inequalities. By system I mean set of two or more inequalities together. So we are going to solve them simultaneously. We will solve each inequality separately at first. We will graph them on the coordinate plane, in the same coordinate plane separately. And we are going to take the common region. The common region will give us the graph of a system of inequality. So let's start solving the questions. First question, example 1. It is y is less than or equal to negative 2x plus 4, y is greater than x minus 3. So let's solve them separately, one by one. Find their intercepts, plot the points on the coordinate plane, and shade the corresponding region. Do the same for both, and just take the common region. So let's see how it works. The first inequality, y is less than or equal to negative 2x plus 4. You suppose there's an equation first to find intercepts. Y is equal to negative 2x plus 4. Your x-intercept will be found by letting 0 for y. When y is 0, 0 equals negative 2x plus 4. Bring 4 to the other side. Negative 4 equals negative 2x. Divide by negative 2. X is equal to 2. So 2, 0 is your x-intercept. You plot this in the coordinate plane on the x-axis. Find y-intercept similarly. This time your x is 0. When your x is 0, y is equal to 0 plus 4. So y is equal to 4. So those are your x and y intercepts. You are going to put them on the coordinate plane. 2 for x, 4 for y. And lastly, not lastly, we have to figure out what kind of line to use to connect these 2 points. Here we have less than or equal to, which requires using a solid line. So we are connecting them by using solid line. And finally, you have to figure out which region to shade. Since you see there is y on one side of equation, less than or equal to, then you have to shade below the line. So we will use a solid line to connect them and shade below the line. So I'm going to use a graphic tool here. Let's write y is less than or equal to negative 2x plus 4. Y is less than or equal to negative 2x plus 4. So here is our inequality. We used a solid line here. We used a solid line and we shaded below the line because there was less than or equal to. Let's do the same for the second inequality. Let's solve to find intercepts first. Okay. The second one, y is greater than x minus 3. So you pretend that it's an equation. Y is equal to x minus 3. Find x-intercept by letting y to be 0. When y is 0, your x is 3. Do the same for y-intercept. To find y-intercept, you let x to be 0. When x is 0, 0 minus 3. So your y is minus 3. So you get your intercepts, 3, 0 is your x-intercept, 0, negative 3 is your y-intercept. You plot 3 on the x-axis, negative 3 on the y-axis. And then, what kind of line should we use? Look at inequality symbol. We have greater than, requires using dashed line. And about the shading region, this is y alone on the left, greater than right beside it. Y is greater than means we have to shade above the line. So again, let's use this graphing tool. Let's write y is greater than x minus 3. Y is greater than x minus 3. So here is your graph. You have a dashed line. When you connect those 2 points, you are connecting it by using a dashed line. And since that's y is greater than, you shade above the line. And this is your solution for the second inequality. This orange one is the solution of the first inequality. This blue one is the solution of the second inequality. What we are looking for is the common region, the overlapping region. So where do these two colors overlap? Those two colors are overlapping here. So this purple region is our overlapping region. So this is our solution. One more example. Check it out 1a. It's x minus 3y is less than 6. 2x plus y is greater than 1.5. Let's try this one. We start solving the question by finding their intercepts. We have two equations, inequalities. Find their intercepts one by one. First inequality, x minus 3y is less than 6. You pretend that it's an equation. X minus 3y is equal to 6. Find your x-intercept. xy. For x-intercept, for your x-intercept, y is 0. For y-intercept, x is 0. So what happens when y is 0? When y is 0, x minus 0 is 6, so x is equal to 6. When x is 0, what happens? 0 minus 3y is equal to 6. Divide by negative 3, y is equal to negative 2. So your y-intercept is 0, negative 2, x-intercept is 6, 0. You plot these 2 points on the coordinate plane, 6 for x and negative 2 for y, and you connect those 2 points by using dashed or solid line, since that's the okay, since the inequality is less than, we have to use dashed line. And the region we should sheet, we can decide this by using a test point. Remember, we pick a point and try it in the inequalities, original inequality. 0, 0 is the easiest one. So 0 for x, 0 for y. Substitute 0 in place of x, substitute 0 in place of y, and see if it satisfies. You have 0 on the left, 6 on the right. 0 is less than 6, which is correct. Since that's correct, we shade 0, 0. So let's use a graphic tool. You will see the colors, the shading part better. Write x minus 3y is less than 6. X minus 3y less than 6. So we used 6 for the x-intercept, -2 for the y-intercept. Since the symbol is less than, we use the dashed line, and we picked a point 0, 0. We tried it, and we saw that it satisfies the inequality. Since it satisfies, then 0, 0 is part of the solution, so we have to shade the part that has 0, 0 in it. So we are shading above the line then. So if you can see, even though the symbol is less than, we are shading above the line because y is not alone and y has minus in front. So let's try the second one. The second inequality, 2x plus y is greater than 1.5. Intercepts, to find intercepts, you're writing equation 2x plus y is equal to 1.5. Find x-intercept and y-intercept. For x-intercept, your y is 0. For y-intercept, your x is 0. So when your y is 0, 2x is equal to 2x plus 0 is equal to 1.5. So x is equal to 1.5 over 2. It becomes 3 over 4. So it's approximately 0.75. So 0.8. Let's say it's close to 1. For y-intercept, your x is 0. When your x is 0, 2 times 0, 0 plus y equals 1.5. 3 over 2. So you find 3 over 4 on the x-axis, 3 over 2 on the y-axis, or you can use decimals, it doesn't matter. And decide the line that you will use. The line that you will use is the sole dashed line because we have greater than. And finally, you figure out the region that you should shade. We can use a test point 0, 0. This is a way. You substitute 0 for x, so it is 0. 0 for y, it is 0. Greater than 1.5. 0 plus 0, 0 is greater than 1.5, which is false. So we shouldn't shade. Don't shade 0, 0. So let's see how it looks on the graphing tool. 2x plus y is greater than 1.5. 2x plus y is greater than 1.5. So this is the second inequality. You find 0.75 on the x-axis. It was your x-intercept. Find 1.5 on the y-axis. It was your y-intercept. We connected those 2 points by using dashed line because the symbol was greater than. And to figure out the correct shading part, we used a test point 0, 0, and we saw that it didn't satisfy the inequality. It becomes false, so we shouldn't shade 0, 0. We should shade the other part. So this green region is the solution of the first inequality. This purple region is the solution of the second inequality. What we are looking for is the common region, the overlapping region. So we find the overlapping region. This dark purple region is the solution region. This is the graph of this system.